Good evening, ladies and gentlemen. I extend a very warm welcome to one and all present, both online and offline, to attend my presentation on regional assessment of Kharif maize and the future climatic scenarios for Tamil Nadu. So everywhere we hear the word climate change, both in terms of your elevated temperature, rising carbon dioxide concentration in the atmosphere as compared to your pre-industrialization era, and melting of your glaciers and glacier retreating, etc., etc. And finally, it comes into the terms like your food security. Because as we are not going to curtail the climate change impact, the global warming trend to 1.5 degrees Celsius as per the Paris Agreement, definitely the climate change would pose a great threat to the food security. So this picture clearly shows that the number of disasters like your hydrometeorological disasters, this were higher as compared to your pre-industrialization era. You could see from the 19th century onwards, the rate of increase of these disasters has been to the tune of nearly 220 per year. So in the another study by IPCC Assessment Report 6, it has also indicated that the warming trend and the drought would have a major impact on your crop yield, livestock and food security. So this has a high level of confidence, which indicate that certain measures should be taken to elevate the impact of climate change on the food security. The synthesis of observed impacts also says that with specific to the crops like your maize crop, it has both positive and the negative impact as a mixed response in the southern part of your Asia, whereas in the rest of the part of the regions like your other crop categories, it shows totally the negative response, which make an assessment that suitable adaptation strategies should be developed for the crops to sustain under the future climatic scenarios. So to understand or to study about the impact of this climate change, we have a very good tool like your crop simulation model, which has the capability to assess what would be happening to the crops when the elevated temperature along with your carbon dioxide concentration rises to the level compared to your normal level. So existing study already indicated that there is a 4.1% reduction in yield in maize crop as well as 4.5% reduction yield in soybean related to the non-warming period even under the carbon dioxide fertilization effect. So we have chosen for the maize crop since the maize crop occupies a major area in our India, particularly Tamil Nadu after the rice. So we are trying to see what would be the impact it will be creating when there is a warming situation with the respect to the current situation. So for this, the methodology followed is a very simple to understand the concept. That is, we have the criteria to delineate the crops based upon the efficient cropping zone. So for which we have 4 different categories called as your relative spread index and relative yield index, where both two categories fell under the more than 100%. It can be categorized into most efficient cropping zone, and wherever the area is higher, it can be categorized into the area efficient cropping zone, and wherever your yield is on the higher side, you can categorize into the yield efficient cropping zone, and wherever both the relative spread index and relative yield index or seems to be less than 100%, it can be categorized into the inefficient cropping zone. So for the Tamil Nadu area, we have categorized for the maize crop, which are all the districts fell under the most efficient or yield efficient, area efficient, and the inefficient cropping zone. And for each one location, like Madurai and Virudhunagar, has been chosen for our study location. So after this basic study, we need to assess what will be happening for the future trend, for which we have taken the CCSM model, that is the community climate suitable model, and this has been downscaled with the regional climate model for the RCP scenarios. As per the IPCC report, there are 4 scenarios called as your representative concentrated pathways, like your 2.6, 4.5, 6 and 8, and among these 4 scenarios, this RCP 4.5 is considered to be the best suited scenario for the future climatic studies. So for this, we have taken 15 point locations for every district. Depending upon the area size, we can able to delineate the location points, and 15 data points have been taken for Madurai and 4 data points have been taken for your Virudhunagar district. And as I said earlier, the crop simulation model, which is a best tool to see the adaptation strategies, we have taken the InfoCrop model. It is developed by IA or Indian Agricultural Research Institute from India. So it's our own model. So which made to assess the impact of the climate change with respect to the near century period over a period of 2021 to 2040. And the suitable adaptation strategy which we have chosen is the alteration in the sowing window, where the farmers of Tamil Nadu could able to do without any monetary input which is being felt easy for the farmers. So 3 dates of sowing has been taken up for the study. One is a normal sowing window, that is the 30th of June, and early sowing window, that is the 15th of June, and the delayed sowing window, that is the 15th of July. So these 3 dates has been chosen to study about the adaptation strategy. And IDW, that is the inverse distance weightage method, has been employed to analyze the spatial interpolation for this particular area. So from this spatial analysis, we could able to see with the base period for all the historical runs, the mean yield for the Madurai district seems to be 8,447 kg per hectare, whereas for the Virudhunagar district, it is 9,117 kg per hectare. So this was a historical yield which could be retrieved from the maize crop in both the locations. But when we are trying with the projected climatic scenarios with respect to RCP 4.5, for the same date of sowing, that is the 30th June, the normal sowing window, the mean yield has been reduced to minus 29% for Madurai, whereas the minus 31% yield reduction could be visualized for your Virudhunagar district. So with respect to the adaptation strategies as mentioned earlier, the early sowing window also suited to be the same mean yield which has been observed for the 30th June as per the RCP scenarios, whereas the delayed sowing window, that is the 15th July of the sowing window, when we tried, the mean yield has been increased to 11% in Madurai and 12% for your Virudhunagar district. So this delayed sowing window has extended the post-flowering period, which could enhance the yield of maize in both the locations. So this is a take-home message, that is for both the locations like Madurai and Virudhunagar has been chosen as a study area, and the data points has been extracted using the global circulation model and has been downscaled with the regional circulation model. The validation of the crop simulation model has been done with the biometric observations like your leaf area index, 50% flowering, dry matter production, economic yield, and the suitable adaptation strategy followed was the alteration of the sowing window. This delayed sowing window extended the post-flowering period in both the locations and further improved the maize yield in both the locations. I would like to conclude that if there are no options to climate change, adaptation and the adaptation is the only strategy to mitigate the ill effects of the climate change. And finally, I would like to thank my alma mater, Tamil Nadu Agriculture University, Dr. V. Geeta Lakshmi, the Honorable Vice Chancellor, and Dr. Rekha Sinha Madam from ILSI, India, and Dr. Stephen Verde and Dr. Helene, who has made me to present here and present my presentation in the topic. Thank you one and all for your patient hearing.